All right, so first disclosure, I've made a career of talking about things I don't know about or do, so that's why I'm here to talk to you about science today. When I started in open source, I didn't know what to do. All I knew is I wanted my students to make educational games for the One Laptop Per Child platform, so I got a bunch of people who actually were in open source to help me out. Now I run one of the first OSPOs at in an academic institution, and it's an open programs office. It's not an open source programs office because we deal with so much more on a university campus. And that's kind of what I'm here to talk about today. So a lot of information, lots of links in the slides. Check them out on Sched later, and I'll try to get through all this as quickly as I can. When I went to my university president to talk to him about why we should join the National Academies of Science, Engineering, and Medicine's higher education, leadership, and open source, and open science, and open scholarship program, he said, hasn't science always been open? You know, what's the big deal? Scientific method, we're supposed to publish, we're supposed to read, we're supposed to replicate. And I said, yeah, no. So it's different now. The whole idea of journals and replication and all that kind of stuff started in the 1600s, right? There's Christopher Wren in the big hair. The guy with less hair is Tim Berners-Lee, who you have probably heard of, Sir Tim Berners-Lee, right? But the whole reason for the World Wide Web and the HTTPS standard to be created was to speed up sharing of scientific knowledge. He was working for CERN, the European atom smasher at the time. And before digital, before we had the internet and the World Wide Web as spread widely as we did, me being a scientist and spending X number of years doing my science and getting my stuff published so people could get out there and get replicated, it doesn't even get published till other people have been able to reproduce it. That would mean that it could take up to 2.5, 3 years for the certified information to get out there. And Berners-Lee wanted to provide access to the raw research information faster. And so one of the reasons that he took his personalized system of hyperlinked notes and turned it into HTTPS and the World Wide Web was to get the conversations going around the research that was happening in CERN and other places faster. Now that we use this stuff to sell each other, I don't know, lollipops, right? We forget that the whole reason for this was science, right? That's why it exists. And why my program is not an open source programs office is because a lot of universities that are heavily invested in research, RIT is just kind of moving toward being a research university in the last 15 or 20 years. There's lots and lots of support for doing stuff open in science, in scholarship, in research. And you see from those boxes over there, there's a whole bunch of stuff, right? Hardware, software, evaluation, infrastructures, open educational resources. That means the stuff that you use to teach a class, you also put out there for other people to use. Open access publication, open access journals. One of the reasons that science isn't as open as it was in the 16 and 1700s is that we have these massive publishing institutions that have a lock on the publication process, right? If I were a traditional science professor, I get promoted on how many peer-reviewed articles and peer-reviewed journals that I get out there. And that means that there's this whole system of people like me donating our time for free to review other people's work so that large publishing houses can take that stuff, monetize it, kick back nothing to anybody who reviewed or wrote it, and sell the subscription to those things to very, high-end universities, very expensive. It's a blocker, it's a paywall. And so all this open stuff is to get around the paywall. And why we're an open programs office is because even the National Academies of Science, Engineering, and Medicine, when they sent out their letter to universities 2 years ago to talk about their push for open scholarship, they had to write a letter that said, hey, we're getting behind open scholarship, digital scholarship, parentheses. Sometimes that gets called open scholarship. Sometimes that gets called open science, period. New sentence. And of course, We also mean the professions, the arts, the humanities, all those guys as well, right? So open scholarship, open science, they're all blockers, right? So I've been working first on my own and more recently with Karsten Wade of Red Hat. There's a link down there for open work. We're trying to create a published, accepted definition for just open work so that we don't have these barriers between people who want to share work. They say, oh, I do open work. Yeah, my open work is in this space. Your open work is in that space. But we're going to go ahead and work from a level and terminology that doesn't build walls against other people. Does that make sense? So that's one of the things we're trying to do at RIT. There's been a real push in the growth around open science, open scholarship, open work for about a decade and a half. And some of that has been accelerated due to climate change and COVID-19, right? Another way to get around that long publishing cycle that people have been trying to get away from so they can get their research out is a practice of publishing a preprint, right? Now I'm the scientist and I've got stuff that needs to get out there, like, I don't know, COVID vaccines. We really should be getting that stuff out there. We shouldn't wait 3 years to get that replicated and approved in the traditional manner. So you put out a preprint. You publish something that says, here's the paper that I'm currently sending around to journals. It may take however long it takes for formal peer review, but you guys really should read this now. And if it makes sense, start replicating it on your own. Don't wait for the formal publication, right? So digital really helps that. The web helps that. Helps drive that open scholarship stuff. That Scientific American article that's linked there talks about all the reasons why that's important. The speed, the fact that the paywall system with traditional publication locks out liberal arts institutions that don't have a big budget, HBCUs. It's all about access, inclusion, and accessibility is one of the reasons why open science is important. There are many. The Alfred P. Sloan Foundation, which is one of the biggest foundations in the world, has actually been seeking to fund OSPOs within universities to try to help accelerate all of this open work. Some of them, there's about 8 of us now. We were the second. Some of them are very traditional, like an industry OSPO is. Others are also dealing with the scientific data research aspects. There's a group called OSPO++ that's trying to get more civic and more academic OSPOs set up, and they're just publishing new papers now that say, well, there's the traditional academic OSPO, the traditional compliance, licenses, rights, education OSPO, but then there's also a full service OSPO, which I guess we were the first because we were the ones saying we're going beyond just the software. So that's happening. The CHAOS community, for those of you who don't know, the CHAOS community is an open source metrics program under the Linux Foundation. They use their systems to help track the health of your community. How often are people posting? Who's participating? They've got some diversity work that they're doing. They dig through the repos, they dig through who goes to the conferences, and they try to surface what the community behind that software looks like and how they work. This nascent Helios link is the National Academies efforts in trying to make digital scholarship, digital science, digital whatever they want to call it, more available to the world better and faster. So how can you help? Well, we've all heard people say, open source 1 or open source 8 software, right? You've all heard stuff like that. Really, software has eaten science. It's almost impossible to do science without software anymore. Some of it's entirely simulation-based at this point. Some of it's a mix, but there's no getting around the use of software in science. We ran a fellowship program for 2 years funded by the Sloan Foundation where we could provide not money to our faculty, but a team, right? You want to get your work out in the open. We've got a designer, a writer, a coder. We're going to help you get your presence out there, get your information out there so you can try to attract a community around your work. So we offered people like that. We covered everything from the genetics of grapes to computational astrophysics, to sign language literacy for deaf children around the world, leading to written literacy for deaf children around the world, to my favorite one, Project VAIN, Victorian Autobiographical Information Network, best acronym ever. So, but in science, it's everywhere, right? We're using software. Level X, if you haven't seen Level X, they're not open source, but as an example of using technology for games, they make mobile games for doctors where doctors can get continuing education certs just for playing the games. Amazing stuff. They're doing work for NASA. Jim St. Clair is in the audience somewhere. He's going to talk to you a little later today about the LFPH, the Public Health Foundation, for using technology for medicine, right? You can use 3D modeling systems for plate tectonics, for astronomy. There are people printing 3D models for blind astronomers so they can get a better feel for what's happening out there. They've been building molecular models in 3D for chemistry ever since there was 3D modeling software and VR software. One of the first VR software applications is being able to connect the molecules to build new chemical chains. O3DE can do a lot of outreach. O3DE can do a lot of publication, not just to the games programs, but to all of academia, to talk about how that software can better enable. Because if you can write the software to better do the science, awesome, right? And some of these scientists are writing their own software. They're not writing in C++, Royal, I'm sorry. They're writing in Python, Deb. But yes, they are writing their own software. So these are all efforts to improve the understanding of open across the research spectrum. In software now with Chaos, Chaos is now talking to academicians to try to figure out how to surface that work, how to do things like Royal talked about. How do we give credit to people who don't do work that's metricized by a pull request, right? We need to do that in industry, we need to do that in academia. The Mystic logo below is stuff that we're building on top of the Chaos system to help academics do a better job of that. OSPO++, NASEM, Helios, I already mentioned, these are all people who are working within science to make it more open, within research to make it more open. The TOPS logo down there, NASA always has the coolest badges and logos. That's their effort to promote open science and open research. They're going to call next year the Year of Open Science. They're putting tens of $millions into making work more open. It's something that's worth checking out. And they're finally starting to recognize the need for community around open work, right? There's the publication of open work, but the open science folks, not a lot of them are doing community management positions yet. That's something we can help teach them more about. Just this year, the National Science Foundation created this Pathways to Open Source Ecosystems. That's what they call open source communities, right? For the first time, they're actually funding people not to do the dev work, but to do the community building around the dev work. So that's a really big sign. If you didn't see it, last month, the White House announced a new policy out of the Office of Science and Technology Policy, a new memo, recommending that there no longer be a 12-month waiting period for when you publish your data and when it becomes open. And the original guidelines said you had to be a grant program of a certain size to have to follow that guideline. They're now saying every federally funded program should be working to make sure that the results of that work, whether it's art, humanities, science, whatever, they're making the recommendation that it should be open. So that's really big, lots of implications there. The Alan Turing Institute is another one called Open Research Community Building. They're trying to work with that around science and research and other applications, the academic world. LibreCorps is our program where we provide research support, like I just talked about in our fellowship program, for faculty, or pretty much anyone. We started LibreCorps working with UNICEF and the humanitarian community. And we'll get staff and students to work with people who want to get our support to help make their work open. So it's starting, that O3DE people can really help as you reach out to the scholarly community, not just for the tool, but teaching them about the need for community management. Could be really cool. And you're doing a good job on community. This is the second blog post of my first student who I've got doing an independent study on O3DE. He's almost finished making his first contribution. He had to do some rewrites on it. And this is a programming kid. And this is going to feed into the stuff we talk about at lunch. But role diversity is also key. O3DE should be a really great example of role diversity because games need role diversity, right? Not just programmers. So his second contribution, he wants to do some of the HCI work that you're asking for. So kudos to you. I couldn't get his 4th blog post up, which talks even more about how great the community is, because it would have been past the deadline for getting the slides. But good start. Do more. And I squeaked in with 5 seconds left. Thank you for your time.